Today we're going to look at expanding binomial products. The word binomial just means an expression, a mathematical expression with two terms. Bi meaning two, nomial, terms. So expanding binomial products uses the distributive law. Just like we've learnt before, the distributive law, if you have a look back over the expanding video, you'll be able to see and get a reminder for what expanding is. Okay, so if we've got, this is a binomial product, we've got two terms and we're multiplying them together. So we've got two terms here that's being multiplied by another set of two terms. So there's a multiply sign in between the two sets of brackets there. So that's very much like if we were trying to find the area of a rectangle with one side that's a plus b, and one side that's c plus d. You can see that we can actually break it up so that here, this is the c plus d, and this is the a plus b side. So that we've actually got four separate areas that we can actually expand it out into. And using the distributive law, we can distribute the a plus b, the c plus d to the a and to the b, and we get a multiplied by c plus d plus b multiplied by c plus d, and then we can expand it out again, remembering that if we go, we need to multiply the a times the c plus the a times the d, and the b times the c plus the b times the d. And you see there, this is it expanded out. AC plus AD plus BC plus BD. And we can see that on our diagram here. This shape here is A times C. That's AC there, A times C. This is AD here, A times D. This is B times C, BC, and this is B times D, BD. So this is our, if we've split this shape up, this rectangle up, into sub-rectangles. So here C is this length here plus D, so the whole side length is C plus D, here the whole side length is A plus B. This tinier rectangle here has one side of C and one side A, so the area of that rectangle is AC, A times C. Here the area is A times D, B times C and B times D. So if we want the area of the whole thing, A plus B times C plus D, we can also have it as A plus AC plus AD plus BC plus BD, which is what we've got here. Okay, so if we want to expand out this binomial product here, x plus 1 times x plus 5, we can just distribute them out. Okay, so firstly we do x times x there, then we do the x times the 5, so we've got x times x plus x times 5, plus 1 times x, plus 1 times x there, plus 1 times 5. So we can use these arrows if we need to remember the order to multiply them in. Essentially we're multiplying every term in one by every term in the other, adding all of the terms together. So then we've got x times x is x squared, x times 5 that's 5x, x times 1 that's just x, 1 times 5 is 5, so then we've got x squared plus 5x plus x plus 5. We can collect like terms, so these are the only two like terms there, 5x and x. So if we add 5x and x together we get 6x, so we get x squared plus 6x plus 5. Okay, let's have a look at some other examples now. So here we've got three binomial expansions to work with, and we notice that some of them have negatives. Let's have a look at one of the ones that's just got positive, so it's x plus 3 times x plus 5. So we need to do x times x first, then x times 5, so x times x plus x times 5. Then we do 3 times x plus 3 times 5, plus 3 times 5 there. Then we can make that's x squared, that's 5x, 3x, 3 times 5 is 15. Collect the like terms here, 5x plus 3x is 8x, and we get x squared plus 8x plus 15. Here, if we have a look at expanding this out, this one's going to be a bit tricky because we've got a subtract here. We just need to remember that that negative or that subtract sign needs to be carried with the 2. So it's always going to be with the 2 because it always has the sign that's out the front of it. Okay, so if we have then 5x times 3x, 5x times 3x, plus 5x times 7, minus 2 times 3x, minus 2 times 3x, because we've got carrying the minus sign out front of the 2 there. And we've got here minus 2 then, times 7, minus 2 times 7. So here 5x times 3x. Remember that we multiply, that's the same as 5 times x times 3 times x. So we can, 5 times 3 is 15, x times x is x squared. So that's going to be 15x squared. 5x times 7 is going to be 35x. Minus 2 times 3x is going to be minus 6x there, minus 6x. And minus 2 times 7, that's minus 14. So we collect these like terms here. They're the only like terms, the 35x, subtract 6x, and we get 29x from that. So that's the expanded form. 15x squared plus 29x minus 14. Last example now. Here we've got 2x times x, 2x times x, 2x times negative 6. Notice because we need to carry that subtract 6 out the front because it's out the front of at the 6. The subtract sign's out the front of the 6, so we need to carry that. So it's 2x times x plus 2x times negative 6 because it's out the front of the 6 there. 2x times negative 6. Then we do the subtract 1 times x, subtract 1 times x, and subtract 1 times negative 6 because we've got to carry that negative sign, the subtract sign, out the front of the 6 there. So we've got 2x times x, 2x times plus 2x times negative 6, minus 1 times x, minus 1 times negative 6. Okay, so 2x times x, that's 2x squared. 2x times negative 6 is subtract 12x, so subtract 12x. Minus 1 times x is minus x. And subtract 1 times negative 6, it's a negative times a negative, which is a positive, so we get plus 6 there. That's why we get plus 6. So 2x squared minus 12x minus x plus 6, we've got like terms here. Minus 12x minus x is going to be minus 13x, which is taking one more x away. And so I've just missed a squared sign here, but that's okay. 2x squared minus 13x plus 6 is then the answer to that last one.